All right, let's look at the reminders for the course, and then we'll get back to inheritance. All right, your lab number 4 has been released since last Friday, and for your programming test number 3, it's not happening next week, but also pretty soon. Let's look at the timing of your calendar. If you go to the semester calendar, so we are now here, November 6th, over here. 7, I meant. We are here. And for next week, Wednesday, during your scheduled lab session, you got written test number 2. I already give you the guide and also some example questions. So I'm going to confirm about which part of the inheritance will be covered. Most likely what we covered today. Right? I'll confirm. And then the week after, you will get your programming test number 3. This test here is going to be solely based on lab number 4. So you got to make sure you really complete your lab number 4 on your own first, and then you can feel free to look at the solution and grading test after the deadline. So that'll be the plan. All right, so that's about lab number 4 and your last programming test. And the guide for your written test 2, just talk about. And for yesterday, I gave an in-lab demo on how you can program with inheritance, especially how you can use a super and extends keyword. So if you really want to get more hands-on and more spoon-feeding experience about how to use inheritance, you can feel free to check it out. But the same stuff is on the slides. I'll leave the choice to you. And for your programming test number 2, we're still in the process of grading, but we may have to go for the plan that I initially mentioned. It may have to be Monday. If I can make it earlier, I'll try, but for now, you may have to assume the result will be available on Monday. All right? All right, any questions about the course? Yes?
Are we going to have the starting programming test 2 files as we had for the first one?
Okay, so after the result has been released, this one I'm not too exactly sure. So let me decide when I release the stuff. Yeah, let me not say anything yet. Okay, just wait, please. All right. All right. Any other question, guys? Before go ahead. After all, it's still a programming test for this course, so of course you got to know the basic for OOP. But you don't necessarily have to specifically review the details from the previous lab. You don't really have to. But of course, if you're still kind of behind catching up the basics, you may have to review them. But I would say it's mostly the advanced stuff that you're supposed to learn from lab number 4, primarily. Yeah. Yes. Lab number 3, I can double check. Let me confirm when I release the guide. You may need to know something about equals method, so it might be applicable, or copy constructed. I'll confirm. Okay, good question. I'll confirm. All right, any other questions? All right, if no, recap from last time. And then we'll move on to more inheritance. All right, let's take a look. So last time, we actually finished the last bits about composition. Especially, we spoke about the deep copy, right? You want to make sure you really understand what the criterion is about. So for this particular case, you just got to remember, in order to define the copy constructor for directory, in turn, we also make use of the copy constructor from another class, in this case, file. It's a very common pattern for you to follow. So that's about how you can preserve the composition. And we discussed one exercise over here where we change this line and then change that to be here. So rather than making a deep copy of the individual file, we simply copy its reference. And that one there is going to turn out to be a violation of the composition. And exactly how? Please refer to the lecture notes or the recording. Right? That's something we discussed in detail last time. And in reality, you may expect partially your project to be implemented using composition if those parts there are not supposed to be shared. Also, you got another part there that may have to be implemented using aggregation, where aliasing is kind of expected to really into play. So you got to decide which part should be done composition and which one should be done aggregation. And we spoke about this particular example that's more open-ended. Let's say for the book, either this case or this case over here, you may have to choose aggregation versus composition accordingly. So I would say that's something you got to decide. You just got to remember the principle about what's really aggregation and what's really composition. That was the last bit about that lecture there, and then we spoke about inheritance from this example here. So, of course, from now on, I assume that you guys are kind of familiar with this problem over here. We're going to refer to the three classes there quite intensively as we introduce the various concepts for inheritance. And before we spoke about inheritance, it is important to appreciate why, without inheritance, things may not work so well. I don't really necessarily mean programmatically. Maybe if you got other solutions without inheritance, maybe it will work. You might still pass test cases, but it may not satisfy the design principles. All right? So that's something you would like to watch out for. Okay? So design number one over here. So the most critical attribute you would like to see will be this attribute over here. This one encodes the kinds of students we have in the system. In this case, we'll say 1 will be resident students, 2 will be non-resident students, right? That's the essence for this implementation. And we spoke about this implementation here violating 2 design principles. One will be cohesion, the other one will be single choice principle. So these 2 over here. And then we talk about the second design. So the first one here, you really want to make sure you understand how the kind can be used, and also how the individual method should be programmed accordingly using some conditional on the kind. Right? That's what we discussed last time. And the second design is really to fix the cohesion problem by having resident students and also non-resident students class over here separately. Okay? Hi. Are you listening to music? Okay, if you don't mind not doing that in my class, that'll be great. Thank you so much. If you want to listen to lecture, please feel free to stay. Otherwise, I'll appreciate if you don't do that. Thank you. All right. Sorry for the interruption. All right, so the second design over here, we basically got 2 classes over here, resident students and non-resident students. And it satisfies cohesion because we got premium rates only in this class, and we got discount rate only in this class. That's really important to notice. However, it violates the single choice principle very badly because we got so many duplicates in this particular 2 classes. And you can also refer to the slides about how the single choice principle is violated. That's also something we talked about last time. And I will do one more discussion of something that's very important in just a moment. And when you actually do the tracing, this will be some exercise for you. Please take a look at the object structure. Nothing new. That's really something we spoke about since day 1. All right, and then we got our student class. This will be the actual design with inheritance. That's something I would like to recap carefully in just a moment. Before I move on to this final design with inheritance, I'd like to speak about one more thing. If you go to the slide, go to slide number 11. Okay? So we still talk about without inheritance, how can we create another class? And this class is is called student management system. So in this class over here, we want to store students. But there are 2 kinds of students, either resident students or non-resident students. If you recall the design over here, this class over here and this class over here, they're completely separate. They have nothing to do with each other. So how can I store in the student management system? One of the very few options you have is to really have 2 separate arrays. 2. Okay, let me show to you. That's important to actually see. Let me just go to that page. Yeah, over here. All right. You can see we got one array over here of type resident students. We got another array over here for non-resident students. Here we only got 2 kinds of students. If you got multiple kinds of students, let's say 5 kinds, you need 5 arrays. If you got 10 kinds, you need 10 arrays. Not a very good design, to be honest, but it can be done programmatically. So you will need separate counters here as well. And also for individual add method, you got to program them separately. And let's say we got another method over here. Let's say for all the students in the system, we want to register a common course for all of them. In that way, a single loop is not going to do it. You need multiple loops. Each loop is just going to go over one particular array of students and register that course to them. So you got to do that for so many times. So this is why this is not a very good design. Let me make a remark, and I'll show you one link that's on your slide. You may want to explore ahead. So these two for loops over here, the number of for loops correspond to the number of kinds of students. All right, this is really important observation from the design. Always when you have a particular design, think about what if you create another class that's going to collect everything together? What's the consequence of that? So this is a bad thing to have. On the other hand, if you go to the slides, let me show it to you. Again, slide number 11 over here, you will see that at the bottom there is a link over here. It's called polymorphic collection of students. If you click on that, it's going to bring you all the way to slide 83. So this is a slide which will arrive in about 2 or 3 lectures time. This will be the ultimate solution we would like to have instead. And let's have a very quick peek of that. In this ultimate solution with inheritance, you're going to have only a single array as opposed to many arrays. You're only going to have a single add method as opposed to so many add methods. And also you're going to have a single for loop as opposed to so many for loops. So that's the design we would like to have. So when you later study for the final exam, you really want to compare slide number 11 and slide number 83 to see why with inheritance we are able to do things much simpler as opposed to without inheritance. Right? That's some review point for you for later. All right, any question about what we said so far? All right, if no, let's now move back to the inheritance solution. I would like to recap about the code structure over there, and then I will want to say something a little bit different. And then we'll get to this guy here in a moment. All right. This is the code structure that we already discussed last time. I want to say a little bit different things here. So we got student here, the parent class. We got 2 subclasses over here, resident students, non-resident students. Okay. I want to talk about in a subclass like a resident student, what can you do in general? So this will be something that might be useful for your lab number 4. Let's say if you have follower as a parent class, you got subscriber as a subclass. What can you do in the subscriber subclass? So there are certain principles you can actually follow. Okay, 4 things over here. Let's go one by one. So you want to say in programming, or let's say in writing, how about that? Make it slightly informal. In writing a subclass. And the subclass can be either this guy here or this guy here. All right, I'm going to give you an example, maybe mainly for this one here. Number 1. You cannot redeclare inherited attributes. So what do I mean by that? If you look at the student class, we got these 3 attributes already declared over here. Automatically, they will be inherited to resident students. Also, they will be inherited to non-resident students. They will just be inherited. And you simply cannot change their declaration. They are there. You have no choice. Okay? And cannot be redeclared. So for example, if you try to say in the resident students class, if I try to redeclare, let's say string name. If you try that, you can see the name here clashes with the name over here. It will be a compilation error. You just cannot do that. Okay? For attributes, you don't have too much freedom. You just gotta live with them. There will be a little bit star over here, wow, which means something I gotta elaborate a little bit more. depending on how you declare the attribute over here. For example, if you say the attribute here is private, versus if you say the attribute will be something called protected, the consequence will be a little bit different. That's something I'll discuss a little bit later. For now, let's not worry, okay? All right, for principle number 1, that's pretty clear. You just cannot redeclare any attributes. They will just be inherited. Principle number 2. We want to talk about, let's say, methods. Let me say another one. Let's say attributes. If I cannot really redeclare inherited attributes, can I add new ones? Yes, as many as you like. You can add new attributes or new methods. And in this case, what do we have? You can see in the student class over here, there's a parent class. In the resident students class, we actually got a new attribute here, premium rates. This is a new attribute. And there's another one which we'll see in the example code, but it's not shown here, set premium rates. So these two are something that's new, that's introduced to resident students class only. Symmetrically, you can see for the non-resident student subclass, you got discount rate, and also you got set discount rates. Okay, so these are the new attributes at the subclass level. Okay, let's now make a notes. So this one here and this one here. So these are the new attributes or methods in the subclasses. Okay, that's number 2. All right, there are 2 more possibilities, which is slightly more complicated. For methods that are inherited to the subclasses, you got 2 choices. Either you say, I'm happy with them, leave them. Number 2, I'm not happy with them, I'm going to override them. So 2 choices. Okay? So let's talk about number 3 first, the happy with them. So you say you are happy with the inherited methods and you will leave them as is. What will be the example? The register method in the student class, let's say we are happy with the way register is implemented. It's going to be just followed by both the resident students and non-resident students, just the same. So you can think about this one here is going to be inherited verbatim and inherited verbatim to here. Okay? So this one will be not overridden. That's case number 3. All right? The final case will be the most interesting one, because in that way, you're basically creating a second version of the inherited method. Okay? Number 4, you're not happy, or not satisfied with the inherited methods. In which case, you're going to override it. Override. And one analogy you can definitely see, or something you have seen already. If you recall what we said in the equals method lecture, the object class has the default version of the equals method. And when we create point v1, we didn't really override it. So we keep the original version. On the other hand, when we created point v2, we actually created an overridden version. So that's the second version. Right? So that's something you want to keep in mind. The same. And in this case, the overridden version that we are creating is here. The get tuition method has version number 1 in the parent class. So this is the parent version. Versus, you can see we declare this method over here, right? And this will be child version number 1. Child version 1. And this one over here will be another child version, version 2. right? You can see that's an overriding. So this one connected here, and also it's overridden over here, right? It's about overriding. Right, so talk about 1, 2, 3, 4. So these three classes, although there are not so many lines of code, but it really illustrated what you can do in general in every subclass. So you want to keep the principle clear in your mind and understand how they are being implemented. So you can apply them to your lab number 4. Yes?
For point number 1,
Yeah.
so I understand that there is a but can we modify the value?
You can modify the value, it's different. So there's a distinction between redeclaring an attribute versus modifying the attribute different, okay? What's the difference? Let's say, for example, if you look at the example I gave to you, let's say for this attribute here, if I try to redeclare that in the child class, it's going to be an error. Versus if you say, let's say, get tuition for whatever reason. If you write over here, let's say, this name is equal to something else. That'll be okay, because the parent attribute is simply accessible from the child class, so that's okay. That one is absolutely okay. I'll put a check mark. All right. Question? The number 4 principle. Okay, interesting. So number 4, it would apply to some extent. So number 4 principle is about overriding. So in some way, you can think about this constructor over here and this constructor over here. They are basically taking the same parameter, but the name by nature will just be different. So it's not really exactly overriding. You can think about, because usually always the constructor name must follow the class name. So you wouldn't say this is overriding, not really. So think about what we're doing here is, when we are defining the constructor for the subclass, we're making use of the constructor in the parent class. That's all we're doing. It's not overriding. So I would say typically, if you don't really well, that'll be a little bit more complicated. Maybe I can speak about it a bit later. But I would say in this case, since you plan to have your own constructor anyway, as soon as you declare that, all the parent version is already gone. So now at this point, in order for me to define the child constructor, I got two choices. Either I just repeat the necessary lines that I used to do in the parent class, which would be violating the principle of single choice. Or I can simply use a super keyword to call the version that's in the parent class. Right? There's no overriding. Yeah. Okay, so the question was about static variable. So that one wouldn't be so relevant to the context over here. Because let's say if I declare something static over here, the static is going to be shared by all the instances of the same class. How about this? Let me talk about this one static, maybe in a different context. That might be easier. Okay, for now, we assume that all the variables are non-static. I'll talk about static maybe in a different lecture. Yeah, just not to get confused. Yes. Yeah, so the question was about, you're more talking about modifier. So here, for parent attribute, for example, the name here, we got a different possibility. Either we leave no modifier, or we can say private, or we can say protected, or we can say public. So these have different consequences to our programming, which I'm going to talk about next one. Not yet. All right, guys, any other questions? Yes? Are you more talking about, okay, so here, for the constructor here, we want to call the constructor from the superclass. That's why we're using this syntax. But for the register, we're happy with it, so we don't really want to override it. So we just leave the way it is. We don't do anything. On the other hand, for the get tuition over here, we somehow want to get its computation. So this is what we have, super.getTuition. That one is going to call this version here to execute it. And then after we get that base amount, we're going to do something additional. It's different. Does that kind of answer your question? Well, you want to rephrase your question. Maybe I'm not understanding you. Well, you want to think about it. Think about it. Catch me after class. How about that? Yes. Yes, that's correct. That's something also to do with protected, etc. Oh, I'll get to it. Yeah, good. Yes. Mm-hmm.
But it's still a resident student.
Good question. So you can imagine that when we actually call the constructor over here, we are trying to create a resident student objects for sure. And then here we say super, and then we're going to go to this here. That is to say, in order to create a resident student, part of the attributes will be inherited from the student class. So that's why we can simply execute these two lines. And these two lines are really meant to initialize name and also register courses, which will be okay because both attributes will be inherited to the subclass anyway. So that's why we can do it. But the big picture is we're still trying to create the resident student objects. But just on its halfway through, we can reuse how we create a student objects. But after all, we're still creating a resident student object. Make sense? Good. Just to be sure. All right. So that's about the important principle for you guys to remember and just apply. The more you apply, the more you will remember that by your heart. Okay, so let's now go back to, okay, so this will be the next topic. Before that, let me just say one more thing. Keep forgetting. I want to speak about very briefly how we trace the code for parents versus child objects. Let's say this. We got three reference variables. We got S, RS, and NRS. At one time, we're going to call the constructor from students. We're going to call the constructor from resident students and also from non-resident students. So accordingly, we got students, resident students, and non-resident students. But how do we visualize them? There is some very important detail you need to be sure you don't forget. Let's talk about students. Students is here. And that one is already the top of the inheritance hierarchy. So we only need to include the name, courses, and number of courses. That one's a simple case. Okay? So you can think about the name, courses, number of courses. So these are basically just here for the parent objects. You want to make sure you include them. But now for the subclasses, okay? If you remember principle number 2, the child object or child class can add new attributes or methods. So that means your visualization for the child objects potentially can be bigger, right? So now I want you to look at the child object from two parts. Think about this part over here. I'll make it thicker. Think about this part over here. You can see the name, number of courses, and courses. And also this part over here. So these are the inherited parts from the parent. Okay? Inherited from students. Okay, that's something you want to remember. And there will be additional attribute that might be unique to that particular subclass. For example, you can see for resident students, we got premium rates and set premium rates. Right? So that's why you will see that the premium rates over here is something you have to make sure you include. That one corresponds to over here. Symmetrically, you can see that we got discount rates and set discount rates. So these are unique to the non-resident student class, which is over here. So you can try to understand this part here about the discount rate. This one here is connected to the additional attributes that you declare over there. Recap. For child objects, you got to include all the attributes inherited from the parent class, plus any new attributes in that particular subclass. And this is very important to really remember, because later on today, we're going to talk about what does it really mean when you declare a reference variable of certain static type. The associated expectation is going to depend on the attributes in your visualization. That's something we'll get to a little bit later today. Okay? Any questions? All right. If everything's good, the final thing before I talk about visibility, so this will be some new piece of code over here, not completely new. This is something I went over in detail yesterday in the lab. So for those of you who might need some assistance on understanding this piece of code, you can refer to the in-lab demo from yesterday. It's not very long, about 30 minutes. Especially, I want you to pay attention to several things. Okay, I'll just highlight them, but you can see the detail in the recording. Number one, you can look at the constructor call here and also here. This one here is trying to create a resident student object, and this one here is trying to create a non-resident student object. Both of them will, in turn, invoke the student version. And the way to see that is by looking at the code. We got super keyword used, right, which I just talked about. And also you can verify this in Eclipse by stepping into the constructor call, right? That's something you want to, first of all, see. And the second thing is about the register, number one, and also here, register, all right? So Jin over here is a resident student. Jeremy here is a non-resident student. But the register method here, there's only one version. If you look at the code here, student class has the register method, and we're happy with it. That's case number 3. So we didn't override it in here or here. So there's only one version here. So if you step into, you're going to see that there's only one version that's going to be invoked. So the version in students invoke. All right. And the final point to really see is this. The get tuition and also get tuition. All right, these two. Dynamically, Jin points to a resident student where premium rate applies. Jeremy dynamically points to a non-resident student where discount rate applies. If you try to do Jim.getTuition over here, it's going to invoke the version of getTuition from resident students. On the other hand, when you say Jeremy.getTuition, because Jeremy dynamically is pointing to non-resident students, it's going to invoke that version there, which is, for example, you can see getTuition. That one there is going to use discount rate. All right, so that's a third thing you want to verify yourself too. So this will invoke, number one, the specific child version. But number two, if you remember in the code, let me show you very quickly. Here you can see we say super.getTuition. We also say super.getTuition. So in each version there, we also first call the parent version as part of its implementation, right? Number two, both first invoke the get tuition from students. All right, both points are important. All right, number one and also number two. All right, so when you study this piece of code, these are the 3 things I would like you to highlight. Right, make sure you understand these 3 points. But if you want to see exactly how they can be verified on Eclipse, that's something I did yesterday in the lab session. All right, any question? All right. If you guys are fine, then I would suggest we talk about visibility. All right. And let me go back to the slides. And before that, let me tell you where you can find the example source code for visibility. If you go back to the lecture site over here and scroll down all the way to the bottom part about inheritance, you will see that we have something here under the codes section. You will see visibility, classes versus attribute methods. That's something I'm going to talk about. So I will mainly talk about exactly how you can understand the issue here, but to really for you to see how things work at Eclipse, you really have to import a project and try it out yourself. I already did most of the work for you over there, also with comments. You can definitely study that on your own. But let's now take a look. Now we are making the following assumption. Let's say we have a project in Eclipse, collection of stuff. That's the project name. At the second level, we got packages. We got animal as a package. We got furniture. We got shape. 3 packages. Under the animal package, we got cat and dog classes. We got chair and desk, also 2 classes. We got circle and square, also classes. All right. And if you go to the Eclipse code, font size is a little bit small. But if you go there, you will see very similar directory package structure. For example, this one here, you will see animal, furniture, and shape. If you expand the package, also those classes, right? So it really corresponds to the slides. And let's talk about some rules. Visibility. Before that, let me give you some general idea here. Okay. So the visibility really has to do with something called modifier. So modifiers in Java. So there are 3 modifiers. Number 1, we may get something private. Number 2, we might get something protected. Number 3, we might get something that's public. Number 4, no modifier. That's also one option. And all of them, somehow, you got to think about whether they should be applicable to when they are applied to classes. For example, if you say public class versus non-public class. Also, we're going to talk about when you apply them to attributes or methods. That's the outline of how we're going to talk about this topic here. Okay? And one more thing to say, the protected over here has something to do with inheritance. But I'm going to explain how exactly. But this one has to do with inheritance, which we're going to see. All right. Let's now talk about the modifiers for classes first. When you talk about modifier for class, there's only one modifier possible, just public. You cannot say private class something. You also cannot say protected class something. You just cannot. Either, there are only 2 options here. Either you say, only 2 possibilities. Let's say within the furniture package, we got a class chair without any modifier. Versus within the same furniture package, we got class chair, but now we put public modifier in front. Right? These are only the 2 options you can have. And different modifier option is going to give you different consequence of the visibility. Okay? And here's the principle. When you have no modifier, that means the class is visible within the same package. That means in another class desk in the same package, I can import chair, no problem. I can use it. On the other hand, let's say I'm not in a different package in a class. Can I import chair? I cannot. Easy. And how do you verify this in Eclipse? I'll show you just one example. If you go back to the project there. So the very first one called the package level class. If you open the furniture package, if you look at the chair class, you can see I just say class chair. I didn't say public class chair, right? Just that. And then that one there, I was trying to access it or import it from another package shape. And then I got square class. And I tried to import furniture.chair. It wouldn't allow me to do so. It's a compilation error. Right? So that's how you verify the different rules that we talk about in the slides. Everything is here already. You just gotta make sure you go over them and make sure you understand. Okay? That's the first one. So the only remark I would like to make will be this. When you actually got no modifier, this will be package level visibility. Visibility. Versus when you got a public keyword. Okay? Public here. That means it's more like a called universal visibility. It's visible everywhere in the projects. Universal visibility. All right, that's about visibility you have to know for classes. Either public or not public, easy. Only two possibilities. And let's now take a look at attributes visibility. And the way we understand visibility for methods will just be the same as attributes. So we'll only need to talk about attributes. And for attributes here, we got 4 possibilities. Okay, so if you remember the list I gave to you, we're going to talk about private, protected, public, and no modifier, one by one. All right, and I summarize it already in a table over here. That's something you'll be expected to know. We're going to go over row by row. Okay, let's now start with private. Let me talk about let me help you understand the table. We got 4 different possibilities for the modifier: public, protected, no modifier, private, right? These are the 4 possibilities. Visibility can be just within the current class. It could be within the resident package. It could be within the subclass in the same package. It could be within a subclass in a different package. For example, let's say the chair, it got 2 subclasses. Bubble chair extends chair, and bubble chair is in the same package. Versus, let's say, rocking chair also extends chair, but for some reason, it's not under the shape package, right? So now, we gotta think about how the various modifier is gonna impact how visible the attributes are. Right? Let's take a look one by one. Let's start with the first one. What about private? All right. So let's say we got a private attributes over here in chair. So private over here, and that's called W. According to the rule, it's only visible in the same class, nowhere else. What that means is if you got W over here, W can only be accessed within the chair class. It cannot be accessed by the desk that's in the same package. It cannot be accessed by bubble chair, which is a subclass, also in the same package. No, it cannot. Also, it cannot be accessed by any other classes in different packages. So private in some ways is very simple. All right? So what you really got to remember is as follows. For W here, it is not inherited. To subclasses. This is important. This is to say, let's say we got a student class. If I declare the name, registered courses, and NOC as private, then the example wouldn't work anymore because all those attributes will not be inherited to resident students and non-resident student anymore. So got to remember, when you declare private, that means it's really within the current class and nowhere else. Okay. You might be wondering, what if I want to make it available to subclasses, protected, which I'll get to. Okay. The second possibility will be, let's say, no modifier. Okay. According to the rule, no modifier, it will be available within the same class. Also, it will be within the same package, including classes that's either subclass or not. Okay, let's see how. All right, for this second one here, I'm going to say, let's say I got another attribute over here, W. Sorry, X. Beg your pardon, X. If I don't put any modifier for X, that means it is available within the same package only. which include, number one, it will be the bubble chair, that is a subclass. Also the desk, that's not a subclass, but that's okay, it's in the same package. But would it be visible to rocking chair? No, not in the same package. Would it be visible to cat? Also not in the same package. So whatever you got, no modifier, is really about the same package. Okay? Protected. This one here would be as if, let me tell you some interpretation here. It will be as if, number one, package visibility plus subclass in some different package. So what do I mean? Let's see. So you can see that we got Y here. So Y, let's say we declare Y to be inside the chair. That's protected. Well, visibility rules tells you for protected, it should be within the same package. Oh, sorry. It should be within the same package, this part here, and also for any subclass that's in a different package. That'll be okay. All right? So within the same package, you can see either it's a subclass or not, doesn't matter, within the same package. And also this rocking chair in a different package, but that's okay because it's a subclass. What about circle? No. It's in a different package, but it's also not a subclass. How about cat? No, it's not a subclass. Protected. Finally, public. For public, it's also very straightforward. When you say public Z, it's basically visible to everywhere, just public, okay? You'll be available to cat, to dog, and also to every other class in the same package, and also every other class in different package, everywhere, right? That's public. So these are the 4 modifiers that are possible for attributes that you are going to make sure you know, all right? Questions? Yes. You cannot have a private class. Remember, good. So that answers your question. You cannot have a private class. You can only have either package level class without modifier, or you have a public class. Mm-hmm. Good. One more thing to say for protected. What will be the principle for protected attributes? I would say typically, let's say if you decide to have an inheritance hierarchy, let's say you got class A over here, and then you got class B over here, right? A and B can be anything. For example, let's say A could be follower, B could be subscriber, right? Like in your lab number 4. One possibility you can try on would be you can try to make step number 1. You can make all attributes private. That's what you can try to do to begin with. You should really try to avoid making an attribute public. That's really bad practice. You should really try to avoid. If you make all the attributes private in the first place, that means none of them will be inherited to the subclass. But as you do more developments of your projects, you might find that some of them should really be inherited. In that case, change them to protected on demand. That'll be the best way to really do. You don't really want to say everything should be protected in the first place either. That's also lazy. You want to really make attribute protected when necessary. Okay. So that's step number 2. As you discover necessary, make attributes protected. So that will be some workflow you can try to follow. Go from private into protected. Okay. All right, if you go back to the slides, okay, that's something we already talked about. And then also visibility for the method, it will be the same principle as attributes, so we don't need to repeat, just the same principle. Okay, we got private, yep, just the same. That's something we also annotated on the page already. And this is just to say a little bit more about when you should really use protected modifier, and that's also something I just sketched with you. So you should only use protected if you want to make them visible to subclasses, either outside or within the same package. Okay. All right, that's protected visual explanation, which I also did. And that's the table. All right. And when we look at the slides, usually I don't really want to get into the discussion for the modifier. So typically, I just leave no modifiers. But for your lab and for your programming test, you can try to get better practice for the modifier, which I already spoke to you about. All right, any question about modifier? Yes. Oh, go ahead. Mm-hmm. Mm-hmm. I see what you mean. So you can think about, yeah, in some way protected will make it visible to all other classes, including non-subclasses visible. So that's some decision you have to make. But if you believe that, let's go back to the diagram here. Yeah, of course, if you want to, well, these are only the 4 choices you have. So let's say between these two, private and also, between private and also protected, right, over here. If you believe all the attributes should not be inherited, but in that case, you shouldn't really get inheritance in the first place. So I would say it is okay to really say I only get the attributes visible not only to subclasses, but also non-subclasses within the same package. Usually within the same package, it's okay to share the different attributes together. Unless you think something that should be exclusively just for that particular class, you'll keep them private. Yeah. Question? By the compiler. Yeah, correct. That's different. Yeah, what I really meant was something like this. So here, it says that you cannot have modifier private. That's what I meant. Okay. When we spoke about inner classes, it's something different, which we wouldn't touch upon. That was a bit too confusing to talk about in this course. But you got to remember, you cannot have private modifier. You're going to get some error, compilation error. Okay. Yeah.
Save time. Is there any assertions we have to worry about if we make something private versus private versus protected?
Yep. So for your programming test number 3, I think getting the modifier to either private versus protected, it doesn't really matter. The assertion you in general cannot really check it. So I would say as long as you make the programming part work, that would not be our concern to your modifier. So you can use any. Yeah, you can, because lab number, programming test number 3 is going to involve inheritance, you will be definitely safe if you just make everything protected. Yeah, that's fine. But I think I maybe worry more about how you can make it more fine-grained, about categorizing different modifier, maybe for the lab. Yeah. For the programming test, you can make everything protected. It's not a big issue. Yeah. All right, any other questions about visibility? Yes? Compilation error. Okay, yes. So well, the thing is, yeah, so for visibility, if you write something that's against the visibility rule, you cannot even execute your code because it doesn't compile, right? So for example, this one here about referring to some package level class in a different package. In that way, it will give you a compilation error. In that case, you cannot even execute the code. Right? Good. All right. If no question here, all right, let's see. So the next one will be this. Okay, so guys, why don't we take a very short break by taking attendance, and then we'll come back. All right, so before the break, we spoke about the visibility. That's very important. Make sure you follow the principle and look at the projects I made available to you. And we want to talk about 2 things, hopefully, by the end of the class. So number 1, I want to talk about something called expectation. Okay. This will be some foundation that we're going to need very badly for next week as well. All right, so I'm going to do exercises together with you. I'll make it as logical as possible. Okay, but let's see. Let's say we got 3 reference variable. We got S, we got RS, we got NRS. From what we spoke about earlier about static type. Static type simply means declare type. So we got students, we got resident students, we got non-resident students, right? So these are the static types. Okay? Let's make that note first. So all these are the so-called static type. And the static types determine what I call the expectation on the reference variable. So what do I really mean by expectation? Whenever you want to ask yourself, what's the really expectation on a particular reference variable? So expectation of a reference variables determines the range of attributes and methods that can be called on that variable. So that's the definition, but we're going to see exactly how that can be applied. Right? Expectation is really about the range of attributes and methods that you can call on that particular variable. All right? If you're trying to call on a reference variable within its expectation, it will compile. If you're trying to call on a reference variable that's outside its expectation, it's not going to compile. So we're going to see the following. This table here is going to somehow enumerate all the possible method call or attribute call that we can have on our student, resident student, and non-resident student example. So for example, you can see I can write s.name. I may write s.get tuition. I might write s.set premium rates. These are all possible. But being able to write it doesn't really mean it's going to compile. So we're going to decide it. Okay? Before that, I want to give you some background information. Number 1 is about the static type. Number 2, if you look at the expectation here, student class over here, this is a superclass, which is already the top of the hierarchy. It doesn't really inherit any other attributes from another class, in this case, right? So the expectation we can have will be the name, the courses, NOC, also the register, and get tuition. So these are all part of the expectation for the student class. On the other hand, for resident students class, it's a subclass. Number 1, it inherits all the expectation from its parents. Number 2, whatever new attributes and new methods you declare in this new class over here, it adds to its expectation. Okay? That will be the second thing you want to know. You can think about the expectation of the resident students will be 2 parts. Number 1, it's going to inherit all the expectation from its parent class, which will be students, plus all the new attributes and methods. In this case, what would that be? Well, number 1, for the student part, it's going to be name, courses, number of courses, register, get tuition. And for the second part, it's going to be premium rates and set premium rates. Everything added up together will be the expectation for this subclass. You do the same for non-resident student as well. And now we've got to fill out this table. So give you guys 1 minute to think about, right? We got so many entries over here. I want to know, for each entry, I want to either have a check or cross. For example, if I got rs.register, if that compiles, I should really put a check. If that does not compile, I should put a cross. All right? Why don't you guys take 1 minute to think about how we should fill out this table? There will be a pattern that we can generalize from this table here. this exercise here is very foundational because now we only got 3 classes. If I give you more classes and more complicated relationship for inheritance, you also need to figure out, right? Okay, 20 more seconds, okay? All right, let's take a look. Okay, let me ask. Now let's talk about S, which is declare type students. Can I say S.name? Yeah. Can I say S.register courses? Yeah. Can I say S.NOC? Can I say S.register? Good. Can I say S.get tuition? All these correspond to 1, 2, 3, 4, 5. Can I say S.premium rates? No, because that one only belongs to here. Also, I cannot say set premium rate. I cannot say discount rate. I cannot say that. Okay, good. So these are all fine. These are not good. First row done. Let's talk about second row, which is subclass. Can somebody tell me what's gonna compile, what's not gonna compile for this row? Anybody want to try? 1, 2, 3, 4, 5, 6, 7. Will all compile? Okay, I agree. Okay, you're saying these 2 are not going to compile, right? Okay, this part over here will be the inherited expectation from the parents. They're all fine. And these 2 are the new attributes and methods we declare in resident students. And these 2 are basically something from what we call the sibling class. They are not good. All right, let me write it down over here. So this part is good. This part is also good, but this part here is not good. And we actually have some terminology here. When I say the resident students and non-resident students, they have the same parents. So we say they are sibling classes. Usually sibling classes, they will have some overlapping expectation, which is inherited from their parents. Okay? All right, what about the last row over here? Right? If we follow the same logic, so now this part here should be good, inherited from the parents. And these 2 should not be good because they belong to the sibling class. This one here is good because they are newly added to this particular class, right? Let's now try to generalize this quickly. Okay. Number 1, you can think about this part over here will be the inherited expectation from the parents. Inherited expectation from the parents. And this part over here, like here and here, so this corresponds to the new expectation only introduced at the subclass level. Okay? That will be the new expectation introduced in the subclasses. And finally, these 2 parts, this one here, and also this one over here. So these are the 2 that are not relevant. They're the siblings expectation, which has nothing to do with you. All right? Okay, so this one here, oh, sorry. So this one here, and also this one here, okay? They are the sibling expectation, okay? Which are nothing to do with you. So they are not part of your expectation. All right, any question about this? All right, the final thing I would like to talk about is this. I want to give you some intuition about polymorphism, okay? let's say we still got the same classes, students, resident students, and non-resident students. And in your mind, it should still be very fresh about expectation for all the three classes here, being the static type. Let's now say the following. We have S, we got RS, student and resident students. Okay? By line number 1 and 2, I basically got, let's say, S pointing to a student objects. I got RS pointing to a resident students objects. And I'm just going to highlight to say these are the static types over here. Dynamic types would be students versus resident student, just happen to be the same. Now, question for you. Now I got two possibilities for the next line. Either I can say S is assigned to RS, or I can say RS is assigned to S. I don't really mean to execute these two lines in sequence, not really. Now you have a choice to make. For the next line, I can either say option A or option B. One line compiles. The other line does not compile. Anybody want to share? Which line do you think intuitively to you should compile and the other one should not? And give me some reasoning. Anyone? How about I try with you? Okay, tell me which line wouldn't compile. The second one wouldn't compile? Okay, what's your reasoning for that? Okay, getting there.
Resident students have some special classes that the student doesn't have.
Okay, good. Yes, definitely. I think you guys actually contributed very good insight over here. So it turns out this line does not compile, but this line does. All right? However, there is something that, okay, what about a rule? The rule is right-hand side to have the static type. So you can see RS was declared to be resident students. So static type of some subclass. And the left-hand side over here could be the static type that's of some parent class. So it is okay to assign something that is a resident student into a student, but not the other way around. So the final bit for this lecture here, I would like to show you something reasonable, like a logical. Because just memorizing the rule might be okay for this course, but it wouldn't lead you far. At some point, if you forget about the rule about which side should really go, you really want to be able to derive this yourself, right? That's something I would like to do. Okay. Do you guys know about proof by contradiction? Right? It goes like this. I assume something called P. And then I try to do something that follows P. If I can somehow prove something that's false, I will know that P itself should be false as well, right? Let's do something very similar, okay? Let me just do that. So this guy here, line number 5, is actually not valid. Let's assume that should be valid. Step number 1, assume RS assigned to S compiles. If somehow I can show you that by following this particular compilation at the runtime, it can lead to certain thing that's disastrous, maybe a crash, then that would mean my initial assumption should be wrong. So this line here should not compile, right? That's what I'm going to show to you. All right, so let's assume that it will compile. So what does it really mean when I say this line will actually compile? That would mean I will be able to do some reassignments. So I will be able to reassign RS into whatever S is pointing to, right? So if I follow this reassignment here, RS, rather than pointing to here, is now going to point to S, right? No. So what I did was I just execute the reassignments. And what follows is going to depend on your understanding from earlier page over here. We want to talk about, given that RS was declared to be a resident student, what will be its expectation? Expectations of RS. Okay, I'll put a star here, put it here. I know that for residents, we can see RS was declared to be resident students. That will be expectation. Resident students should have basically premium rates, name, courses, number of courses, right? I should definitely expect to do RS dot name. I should expect to do RS dot number of courses, RS dot courses. Also, I should expect to say RS dot premium rates. The reason that I should really expect this one here is because RS was declared to be resident students. Now, at the runtime, what's going to happen if I execute rs.pr? Does the dynamic object here really contain PR? Not really, right? Because you think about this is a student objects, right? And when we talk about visualization, student objects should contain the name, the courses, and number of courses, no premium rates. The expectation for students only contains what's declared in the students. There is no such thing as premium rates. But our initial assumption allowed the reassignment to occur. In this way, we're basically calling rs.pr. We're expecting something from this object here that is not going to meet the expectation. So we're going to have crash. All right? So this one over here is going to give you crash, because the students objects does not have PR. This is a very important reasoning for you. This tells us our initial assumption was wrong. That means RS assigned to S should be not compilable. So this is the conclusion. Right, so the reason I'm showing you this kind of proof over here is in case you forget about which side you should really go. That's the way to derive. Of course, you don't necessarily have to follow step 1, step 2, step 3, but follow your way to adapting. But this is really important to note. All right, any question? All right, so this one here is really important. So let me give you some idea here. We still have 3 minutes. Why don't we do one exercise together? A. B here, C here. All right? C, object 3 will be new C. All right, let's try this. O1, O2, O1, O3, O2, O3, O2, O1, O3, O1, O3, O2. Consider each one of them in isolation. All right. We can do some of them. We still have 2 minutes. Okay. Should the first one compile? O1 declared to be A, O2 declared to be B over here. It is okay to assign something that's child to something that's parents. When things get symbolic over here, memorizing a rule may not be the best way to go. So you really gotta kind of remember the reasoning, which I showed to you. That's why it is important over here, okay? So this one here is okay, right? One example. Let's have another one, for example. What about O2 is assigned to O1? No? O2 declared to be B, which is a child class. O1 declared as A, which is a parent class. You cannot assign parent to child. All right, that's why it wouldn't compile. Right, you can do the rest on your own. Encode it to Eclipse, which is follow the principle I mentioned, and that's how you figure out. All right, so this will be how your written test number 3, written test number 2 will cover up to. I'll confirm the slide number. All right, study this, and then I will see you next week.